Hello everyone, welcome. We are on our second week of quarter four, which is really exciting. We're going to start this lesson with a Peardeck, and we are in module 6 right now. And this is all going to be about polynomials, but to be comfortable with polynomials, you really want to feel confident looking at exponent properties. So we're going to do a Peardeck and a lesson all going over all these different types of exponent properties in 6.1. Push ahead to slide 2 when you're ready. And this is just a nice picture that shows all the exponent property rules. We have the algebraic example and then also a literal example going through each of the rules. When you're working with exponents, there are many properties that allow us to simplify and combine powers. So we're going to work through all these properties in the slideshow today. And I will say, when we have a power, the exponent is that little number in the corner. Right? So whenever we're trying to figure out what our exponent is, it's always that little number that's miniature in the corner. And of course, as a reminder, if this is a 3, then it means our base, which is x, is being multiplied by itself 3 times. So x to the third power, or x cubed, is x times x times x. So we have our base, and then we have our exponent, okay? And all of this is a power. So there's the power of a product, power of a power, quotient of powers, negative exponent, zero power, rational exponents, power of a product, and power of a fraction. And we're gonna look through each of these one slide at a time, okay? So this is just a good thing to come back to get a full review of all of the exponent properties. The first one on slide 3 is the zero product property. It should not say zero product. That is a typo. That is funny that I did that. Yeah, we can just call it the zero exponent property. And what it tells us is that any non-zero number raised to the 0 power is equal to 1. So anything that's raised to an exponent of 0, like we have here, just equals, just equals 1. So x to the 0 power is 1. 7 times x to the 0 power. So first we would do x to the 0 power, which is just 1. So we have 7 times 1, which would get us 7. Y to the 0 power, 1. Anything raised to the 0 power equals 1. 4 to the 0 power, 1. 2 times 3 to the 0 power. So first we would evaluate 3 to the 0 power, which is 1. So we have 2 times 1, which gets us 2. So whenever we're working through simplifying, we always want to make sure we're doing our order of operations. So starting with any parentheses and then exponents. So anything raised to the 0 power is going to simplify right to 1. Slide 4, when you're ready. There we go. Slide 4 is the product rule. So if you are multiplying powers or exponential terms that have the same base, you keep the base and add the exponents. So for example, both of these bases are x. So essentially what we have here is 2x's, or an x squared, times 3x's, or x cubed. So to simplify this, the base stays the same. So notice my base is still x. And then I take these exponents and just add them. 2 plus 3 is 5. So this is an x to the 5th, right? We have 5 total x's that are being multiplied. You can always break down exponents and give yourself a visual to see what's happening and what we could cancel out or combine. So it's really good to feel confident in how to expand those powers. In the top right, we have h to the 4th times h to the 5th. Now again, they have the same base. The base is h. We have 4 h's that are being multiplied, and then we have 5 h's. Add them together. 4 plus 5 gets us 9. So this simplifies to an h to the 9th. So again, when you're multiplying, which is what we're doing here, keep the base, add the exponents. For the next one, we have 3y cubed times 2y to the 4th. So the first thing we'll notice again is that our base of y is the same, but we can multiply this 3 and 2, these coefficients, because everything is being multiplied here. 3 times 2 gets us 6, and then we have a y to the 3 plus 4, which is 6y to the 7th. So we multiplied the 2 and the 3, kept that base, added the exponents to get a y to the 7th. Down below, we have a lot going on here, but just do it in parts, right? Everything's being multiplied. First, we have this -2 and this 7, which is going to get us -14, right? Then we have an a squared times an a cubed. Same base, add the exponents. 2 plus 3 is 5, a to the 5th. And then we have a b times another b. So it's a b to the 1st, b to the 1st, so that becomes b to the 2nd. 1 plus 1. Last one on this slide, combine your x's. We have an x cubed times an x. So we're going to get 4 x's being multiplied in total. Y times a y to the 6th will be y to the 7th. Z squared times z to the 7th is going to be z to the 9th. And there's our final answer there for that one. When you're all set with this slide, pause the video if you need to, and then push ahead to slide 5. So when we're multiplying, we add the exponents. When dividing exponential terms with the same base, keep the base and subtract the exponents. And I'll show you why in the example up top here. But what we're going to do here, x to the a over x to the b. Here we go. The bases are the same. They're both an x. So this becomes x to the a minus b. We just subtract the exponents. So in the top right, we have 27x to the 5th times 3x squared. So I'm going to show you why we subtract. So we have a 27. Actually, I'm going to type it. 27, and then we have 5 x's. 27 xxxxx. And that's divided by 3 times an x squared, which is 2 x's. Now what we're going to notice is 2 of these x's can cancel with 2 of these x's. And that leaves us with 27 divided by 3, which is 9. And then we have an x, and we only have 3 x's left, so an x cubed. So however many variables, in this case it's x, that we have in the denominator, we had 2, and those 2 canceled out on the top. So essentially we do 5 minus 2, and it's going to become an x to the 3rd. For the next one, we have 18 divided by 9, which gets us 2. And then y to the 6th divided y to the 4th. So we just do what's 6 minus 4. So that's going to be a 2y squared. because 6 minus 4 is 2. Okay. 10 divided by 5 is 2. X to the 5th divided by x cubed, because again, first we want to focus on where we see the same base. 5 minus 3 gets us an x squared. Y squared minus a y, which is a y to the first, is just going to be a y. 2 minus 1 is 1. So when we multiply with the same base, we add the exponents. When we divide with the same base, we subtract the exponents. Push ahead to slide 6 when you're ready. This is called power of a power rule. So when you have a power, or an exponent, and then it's raised to another power, you are going to multiply the exponents. So this is an x to the a, and then it was raised to a b. So this becomes an x to the a times b, or ab. So in the top right, we have an x squared cubed. And again, you can break this down visually. This is x squared times itself 3 times. 2, 4, 6 x's. And we can simplify that by just multiplying these two numbers. 2 times 3 gets us 6. 7y to the 4th all squared. So we need to square the 7. 7 squared is 49. And then y to the 4th squared, well, 4 times 2 gets us 8. So it's 49 y to the 8th. This 6 is outside of the parentheses, so it's just going to stay as 6. There's no power that's raised to that 6. But then we have a z to the 6th power raised to the 7th. Power to a power, multiply them. So that's z to the 42nd power, which is 42 z's, all multiplied. Last one, z to the 6th power raised to the 7th. Again, here's our z to the 42 times z to the z squared raised to the 4th power. 2 times 4 is 8. And now we can combine this using our past property of product. When they're multiplied, if they have the same base, we add them. 42 plus 8 is 50. So that just combined two different exponent properties. So that gets us a z to the 50th. Beautiful. Slide 7 when you're ready. We just did a little example of this, so that was perfect. This is a power of a product rule. So if you have, so we're looking at this rule. If you have multiple terms that are all being that are in parentheses, all raised to the same power, we have to distribute the exponent to each term within the product. So when we have 7x squared, remember this is 7x times 7x, right? So the 7 is squared, there's 2 of them, which gets us 49, 7 times 7, and the x is squared, right? Because they're all in the parentheses, so that each part of the product is getting that exponent. For the next one, we have x, y, z all raised to the 4th power, so we need to distribute that exponent. So we have an x to the 4th, y to the 4th, z to the 4th. For number 3, we have a 4 squared, which is 16, 4 times 4. And y to the 5th squared, 5 times 2, gets us a y to the 10th. Last one, 5 is outside the parentheses, so it is not raised to the 4th power, so that stays just as it is. A cubed to the 1st power, 3 times 4 gets us an a to the 12th. And a b to the 6th raised to the 4th power becomes a b to the 24th, 6 times 4. I'm going to pause the video here. Check out part 2 when you're ready to keep working through this Peardeck. Nice job, everyone.